Now, question number 4 is on solving algebraic equation. So without further ado, let's try question number 4, part A. So question number 4, part A, I'm just going to write down the equation over here. So we need to solve for the unknown C, okay? So that is the equation over here. So let's do it slowly. So we have 2 times 3C, right? So 2 times 3 is 6, and then I write down the C, and 2 times minus 1 is minus 2, okay? And here we have minus 3 times 2 is minus 6, and we have minus 3 times C is actually minus 3C, okay? So this is equals to 0. So let's group the terms according to my preference so that we can see it easier. So let's group the terms in C together. So 6C minus 3C, and then the constant, which is the numbers minus 2 and minus 6 together. So it's equals to 0. So 6C minus 3C is actually 6 minus 3, 3. And then we put our C. And then minus 2 minus 6 is actually minus 8, equals to 0. So anyway, just to teach you how you can think of this, you owe $2 today. You owe me $2 today. And tomorrow, you owe me another $6. So in total, you owe me $8. That's why it's minus 8 over here. So you can think of it from that angle, okay? So 3C is actually equals to 8, because I moved the minus 8 over, the sign will change, become plus 8. But we don't write it as plus 8, we just write it as 8. It's understood that it is positive, okay? So C, this is 3 times C, right? Then we move it over, it becomes divide. So 8 divided by 3. And we are done with question number 4A. So let's do 4B over here. So let's write down the question. It is f plus 2 over 5 plus 1 equals to f plus 1 over 2. Okay, so the left hand side looks a little complicated, but don't worry. So f plus 2 over 5 plus, so this 1, right, we can write it as 1 over 1, right? It makes sense, because 1 divided by 1 is still 1, okay? So that's all I'm going to do over here. So now we have a fraction here and a fraction here. So recall earlier, to add up two fractions of different denominator, first you must make the denominator the same for the two fractions before you add it up. So in this case, to find that common denominator, we take this denominator 5 times this denominator 1. So that will be 5 times 1. So 5. But this denominator here is already 5, so we don't do anything over here. So f plus 2, so plus. So we need to make this denominator 5. So here I times 5, here I times 5. So it's 5 over 5, which is still 1, okay? So equal, I'm not going to do anything on the right hand side. So f plus 1 over 2. So now we have the same denominator over here. Yes, we can add up the fractions. So f plus 2 plus 5, okay, over 5. So this is equals to f plus 1 over 2, okay? So this is f plus 2 plus 5, which is actually f plus 7, right? Because 5 plus 2 is 7, over 5 equals to f plus 1 over 2. So if you see a fraction equals to another fraction, I can do the cross multiplication, okay? So this is 5 times f plus 1, and this is 2 times f plus 7, okay? So multiply this inside. 5 times f is 5f, 5 times 1 is 5, 2 times f is 2f, and 2 times 7 is 14. So let's shift this 2f over to the left hand side. We get 5f minus 2f. Okay, so remember, when you shift the term from one side of the equation to another, you need to swap the sign, because this is plus 2f because it's positive. So you need to, when you move it over, you need to change the plus to a minus. Now same thing over here. This 5 is a plus 5, right? We shift it over here. So we write the 14. And remember to swap the sign, to change the sign, become minus 5. So 5f minus 2f. So 5 minus 2, 3. And then we write down the f. And then 14 minus 5 is 9. Okay? So this means that f, okay, so this is 3 times f, right? So then if I were to move the 3 over here, it becomes a divide. So 9 divided by 3. So f is equals to 9 divided by 3 is actually 3. And we are done solving 4b, and we are done with question number 4.